On page 605, question 10a, we're looking at first of all, the ionization equations for these acids, and they will only ionize with one hydrogen. As we look for the total acids here, we're seeing them on this page as HClO2, HNO2, and HIO. All of these guys are monoprotic acids, so we only have to ionize them once. Now, the other thing that we're being asked in this problem is to write the equilibrium expressions, or the constant expression. And so let's do the ionization first, and then we'll write the expression. And so let's start out here with what we're given. We always know that it's going to react with water, and this guy's going to be the acid, and this guy's going to be the base because he'll accept the proton from this guy. So we have to look on the other side. We see, like we saw in problem on page 601, that water is a liquid again. The acid is aqueous, just like up here. And we're going to form the hydronium ion, and then we got to have what's left of the acid as the conjugate base. So what's left of this acid when it gives one hydrogen to the water? So first of all, we'll do the hydronium ion, the H3O, 1 plus. Okay, this is our conjugate acid. This guy here is, the next one is going to be the chlorite, ClO2, the chlorite ion, because that's all that's left when we lose a hydrogen. And now this guy is a 1 minus, and this is the conjugate base. And let's tie them together. The acid becomes the conjugate base, which is right here. And the base, this is the guy that accepts the proton, is going to become the conjugate acid. And that's how it all looks together. And now we have our ionization done. Now we got to get the K sub A. The K sub A expression, the equilibrium constant for the acid, is going to be just like in our last chapter. We've got two guys on the other side. Oh, we got to balance this equation, so let's make sure it's balanced. We have 3 hydrogens here, 3 here. We have 1 chlorate ion here, 1 chlorate ion here. And we have that oxygen that was with the water is the same oxygen that's over here with the hydronium ion. So these guys, well, since we have a balanced equation, we have no coefficients. There, it means there's going to be there's going to be no exponent for these guys. So we'll just go ahead and write the hydronium ion, H3O, 1 plus. That's the concentration of hydronium ion. And now this is the concentration of the chlorite, which is a 1 minus ion. These are the products. And underneath the reactants. And now you're going to see the hydrogen chlorate, ClO2, no charge, and that's the only reactant. What's missing here? Oh, the water's missing. Why? Because it's a liquid. So as we're doing this, we got to make sure we don't put that water in there. And this is the K sub A or the K equilibrium constant of the acid, is going to be this expression right here. That's it.